All right, so let's look at this example and use the power property for logs, okay? So now, right here in part A, I would write this as a rational exponent, because we can write this as the natural log of what? The index of the fifth root is also can be written as an exponent of 1/5, right? So we can write this as the natural log of x squared raised to the 1/5 power, and then the power rule for the power property for exponents says that if you have a power raised to a power, then you multiply the exponent. So this becomes the natural log of x to the 2/5. And so now we can use the power property and pull the exponent out, and so this becomes 2/5 times the natural log of x. Now, one thing I want to make sure I add here for you guys to understand is that this equality only holds for the domain of the function, right? So we have to restrict the domain of this function to everything that's positive, everything greater than 0, because remember, logs have to have positive arguments. So if you look at the domain of this one, right, the domain of this one is anything except 0, right? So you can have all the negative values, right? But this one, you can't put any negative values in here. So this equation only holds if x is positive. Okay, so we have to restrict the domain to all positive real numbers. Okay, just keep that in mind. Okay, so now this one. So with this one, it would just be equal to 2 log x. So now again, we got to restrict the domain of this to all positive real numbers. Okay. Because even if you graph this, you'll see that the graphs are different. Okay, but they are the same as long as you restrict the domain to everything greater than 0. In this case. All right.